stuff last semester.
You can get summations, you can get absolute value, you can get everything just by off a window.
How awesome is that?
Did you know you could do the polynomial solver thing too on apps?
I try not to show you.
Yeah. I use it because I'm too lazy sometimes, but it's the same deal.
But when we do stat, calc, linear regression, you can store a regression equation in a certain y1 or y2. Did you know that? I could go down here and I can say second. I guess I have to have something in there, but if you do second trace, it'll come up with your y1 through y8, and you can put that equation in without having to write it down and copy it. It's cool. So
That's cool.
And I don't know how many of you have the. Does anybody have the CE? The CE is rechargeable, and it's lighter, no batteries. And this is not it. This is my old one. But,
I was about to say, it looks just like.
But yeah, it's light, no batteries. But the thing I didn't like that I thought before I jump on the bandwagon and say, order them, it froze several times. Like I was graphing something, and it froze a couple of times. So I'm going to have to think about that. But it was great. It's color. And actually this, I could change the new emulators to the other format for CE, but since everybody has these, I'm going to do that. But I thought that was interesting. But no batteries, wouldn't that be great? If you just recharged it every night? Unless it died.
Yeah, you can put in matrices too on the alpha thing. I remember messing with that last semester.
You mean different?
Like you can go to matrix right there and
oh yeah.
enter and be able to put stuff in there.
It just they just keep improving. So a lot of their stuff was TI inspired. I don't know how to use that. But that's more powerful than probably me.
Yeah.
This is what I want to do today. I want to do 3 things. Just so we don't get behind, I'm going to do a short section that'll be after our test. Then I'm going to review you, and then I'm going to give you your take-home quiz and see if you could work a couple before you leave. Those are the 3 things I'd like to accomplish. So the reason I want to go ahead and do 3.5, which is not on your test, but it's the first section we cover afterwards, I just don't want to get any more behind that syllabus. Because we keep missing Mondays and stuff. But if you look at page 213, this will take no time. Page 213. And we'll see what you think. After we take this test, mostly we learned our rules for derivatives in this unit. Which ones did we learn? We learned power rule. We learned product and quotient, chain. We learned implicit. All right. When we get back from this test Wednesday, next Monday, what we're going to be talking about is what if I gave you number 2, which is f of x equals negative 2x squared plus 0.3x plus 4. And the instructions are find the first and second derivatives. We're going to learn some applications of taking the derivative of the derivative. I'm not going to explain what they really mean too much now, but you can almost think what it is. If the derivative is rate of change, the second derivative is the rate of change of that derivative. Rate of change. Yeah. But right now, can you find the second derivative? That's easy, isn't it? What's f prime?
4x plus 0.3.
Well, what would f double prime be? 0.4. Isn't that easy? The derivative of the derivative.
So that's all we're doing now.
Be negative.
Negative. Thank you. So you got 2 carried. This is usually your notation for second derivative double prime. They might also give you, remember how we would have dy dx? They might have, I think it's d squared log dx squared. I have that on a D2L for next week, but don't worry too much about that. But these are two different notations for second derivative. Just like this used to be. You know this is dy dx. It's the same as f prime. So, I mean, all of them down to 20 are like that, but do you see that certain ones are going to get harder if the first derivative has a product or chain rule? And when you have to do it again, you're going to be in trouble, aren't you? And you're going to hate it. But I thought we would try maybe number 8. See what that looks like. Number 8 says g of t equals t squared times 3t plus 1 to the 4th. Well, the first derivative is the product rule, which helps us practice for the test for this one. First, what's derivative of second? 4 times the inner to the third times what? Derivative of inside. So if I sort of recalibrate that, that's going to be 12t squared. Does that look right to you? For this part. Plus, I have to do it the other way, right? This was first times derivative of second plus derivative of first times original second. You agree with that? Derivative of first times original second. So, but then, you know, you got to do 2 of those each, right? You got to do this one by product, which will be 2 big terms, and then this one by product to do the second derivative. So it gets ugly, doesn't it? So that would be what? First times derivative of second. Oops, does that look good? First times this, the second times derivative of inner, plus derivative of first is what? 24t. What did that exactly plus 24t times the original second function. Now let's do it for the second one. That was the derivative of this by product rule. Now do this one by product rule. First times derivative, second, plus derivative of first times original second. And then I just have a lot of simplifying if I wanted to do it, right? But you see where I'm going with that? You had to be very careful that you did product rule here, like that. That you did product rule for this, which would be this plus this. And then make sure you could simplify a little bit if you had to use it. But that's what we're talking about. The rest of it's just simplifying. But that's first derivative, which we actually did simplify a good bit. And the second derivative, I didn't even attempt that.
Ultimate points on the second derivative.
Oh, that's what I have to show you next week. Concavity and inflection points. Remember how the first derivative, we would set the first derivative to 0 and it would give me what? Wouldn't it give me the max and min? If you set the second derivative to 0 next week, I'll tell you that that's going to help you find the inflection point where it changes from down to up or vice versa. And that's going to give me like, where is it concave down from what to what, and where is it concave up from what. But right now, all we're worried about on this test is the max and the min, right? Next, it's going to be where does it change from concave down. That's just the short version.
You need to do that.
Okay. But I'll vote next Monday. Do you see that in 18, if you had to find the second derivative, you just do the quotient rule, then you probably have to do it again? Okay. I'm not going to ask you in 21 through 28 to find the third derivative. We really don't use the third derivative. They just want you to practice doing it over and over and over again. That would be the rate of change of the finding the inflection point, which I don't know. I haven't ever really used the third derivative. They just did that, I think, for practice on taking derivatives. But first and second, we have good uses for it. You'll find this is coming, and that's not bad. But it's just practice on using your derivative rules. What I thought I would finish this with before we review is a couple of the word problems like 30. That is a good one. 30 says the distance s covered by a car in 2 seconds is given by s equals negative t squared plus, oh, that's 2t cubed, excuse me, plus 8t squared plus 20t, and that's good for 0 to 6 seconds. Find the general expression for the car's acceleration and show the car's decelerating after 2 2/3 seconds. If you remember, if you take the derivative of a distance function, that's the velocity, that's the speed, isn't it? If you take the derivative of the velocity, that's acceleration. So actually, acceleration is the second derivative of the distance. So s prime, this would be the velocity or speed that the car is going. So what is the velocity? The first derivative is, would you agree with that? That's the velocity. Then the acceleration, if you write that here, that's the velocity. The acceleration, the second derivative, would be what? Okay. And what they asked me to find, they said find a general expression for the car's acceleration. Well, here it is. At any time t. That's how quickly it's accelerating, the rate of acceleration. So, what they want you to show that is that if t is larger than 2 2/3 seconds, that car is decelerating. It would be negative, wouldn't it? Because if you put, what is 2 2/3? Isn't that 8/3? If I put 8/3 here, that would be negative 16 plus 16, which is 0, isn't it? So if I go beyond 8/3 seconds, this is going to be negative, isn't it? So the way you could answer that question is, if t is greater than 8/3 or 2 2/3 seconds, the acceleration is negative. For any, like what if you put a 3 in? 3 seconds, negative 18 plus 16, it's decelerating, it's negative. That's all they want you to see. Distance, velocity, first derivative, acceleration, second. And I thought a good one to end this section with is 34. This didn't take long here. 34 says the body mass index measures body weight in relation to height. A BMI of 30 or more is considered obese. BMI of 40 or more is morbidly obese. The percent of the U.S. population that's obese is approximated by this function. E of t is 0 to T plus 0.26 squared plus 0.82 plus 12. That is good for T is in years, between 0 and 13 years from 1991. Okay. Show that the rate of change of the percent of U.S. population that is deemed obese was positive from 91 to 2004. And what does this mean? Okay. Oh, read it again. Show that the rate of change, which means second derivative, right? Not just the rate of change, but the rate of change. Okay. So first, tell me what P prime 2 is. Would that be? How about its second derivative? Nice. Show that the rate of change, either this was positive from 91 to 2004. That means from 0 to 13, right? Well, do you see that? Do you see that if I graph the second derivative, it has a slightly positive slope, doesn't it? It's rising. It's rising. So that straight line is rising. So for all of these values, P double prime would be positive, wouldn't it? So that means that it's increasing at an increasing rate. Right? The rate of change is increasing, it's positive. So it's increasing at an increasing rate. So it's accelerating. Obesity is accelerating. That's the way you think of it. You don't have to do that. But, what's that? But that's all that is asking for. That if you notice that no matter what T you put in here in that interval, it's always going to be positive. Always positive on the limit. So it's increasing and decreasing. So the only ones I would ask you to do from 3.5, which will help us start, I think 4.2 on Monday. Why don't you try on page 213? I'm just saying 1 through 19, every other line, and 29 and 31. That's all I want, and that's not going to be until Monday. That's the assignment after our test Wednesday. So don't worry about that now. And I'll remind you of that on Wednesday. So this is what to expect on your test Wednesday. That's what I would like to say. Test 2 Wednesday. It's going to cover, we said it was 3.1 and 3.5 and 3.7, 3.1, 2.3, 4 and 3.6. We just did 3.5. 3.1, 2.3, 4 and 3.6, and then 4.1 and 4.2. I think that's all I said. What that covers, if you also want to put up here before you do the actual topic, that was quizzes 4, 5, and then I'm going back together. So if you put these 3 quizzes together and review them, that's a good study guide for your test.
Take the average.
What's that?
So take the average and you
Ah, and you said that's not even take the test. That's interesting. Interesting.
do it 2 more days.
2 more days ago? Yeah. I guess I'll just slow it down. The first question you'll see on the test, just like I asked on that quiz, the definition of derivative. Remember how I asked you on that quiz 4, the limit definition, you wrote it down for me? I used to ask people to actually use that limit definition to work the first problem. I might just ask you to write down the limit again, and you can use our rules for derivative. So if I gave you something like f of x equals x squared plus 3, you know the derivative is 2x. But if you said the limit of h approaches 0, f of x plus h minus f of x over h, that would take a page, wouldn't it? But as long as you write this for me, and then you just say, I'm fine. I'm fine. I'm getting softer in my old age. The second thing you need to know are those rules we were talking about. The rules of differentiation. What did we say the rule in Kevin? We said the power rule, product rule, what else? Quotient rule, chain. And I'll list implicit later as a separate topic. What was this? Marginal cost, marginal revenue, marginal profit. Remember our word problems on that? What was marginal cost, revenue, profit? What wasn't it? C prime, R prime, P prime. On that quiz I just handed back, some of you didn't tell me what it meant when you found the marginal profit at a certain amount. Didn't that mean the profit from the next item sold? So if I said, what's the marginal profit for the 5,000, that was the profit from the 5,000 first unit. So some of you didn't like that thing. So make sure you make it. Then we did, after this, we did related rates problems, then implicit differentiation. Remember implicit differentiations where every time we took a y derivative, we would tack on dy dx, and we would solve for dy dx. If I had an equation, sometimes that involved, we did several types. Sometimes if it was something like x squared plus y squared equals c squared, I would have to take the derivative with respect to time, tack it on, 2x dx dt, 2y dy, something like that. Remember that? And we plug in all the values. You remember those. That one's on your take-home quiz in my class. Or related rates. We can set up, it's on in your notes, right? Set up the function. You might draw it. If you could, remember we draw those intersection problems. And then you just add your theory to sometimes I would give you the function. The only other thing, and I ran out of room to add to that, is what we did in chapter 4, where I asked you to find the intervals where a function increases or decreases. Right? Finding the relative max or min of a function. That's the relative maximum and minimum values. And then the last thing we did last time was the absolute maximum. That was from section 4.4. These were 41, and that was 44. Does all of that stuff seem pretty familiar? I hope this does. You'll need to know those rules to find your derivatives. Practice back on quiz 4. The marginal cost, revenue, profit. This stuff is on the quiz I'm about to hand out. So if that doesn't seem familiar, you need to brush up on it. This is your last question. I've got like A, B, C, and D on the quiz. I'll say find intervals of increase and decrease in relative maximum, absolute maximum of a certain unit. Okay. Any questions on what you studied? How you study for it? First thing I would do, I would correct and rework all of these and make sure that this is clear as a bell that you're going to turn it into. If it's not, where do you go? When it's a B, you say, I didn't understand this, and then I'm doing it here. Okay. Yeah. But I'll be here tomorrow. I'll be talking about it. Or tomorrow. If you can call me, or send this down. The hard thing to do is if I'm at home and somebody sends me a scan and I'm going like this, trying to make it big enough to see on the phone. But yeah, if I'm here, it's great. Okay. Any questions? Any homework questions from absolute maximum? So I want to see if you can show me at least 2 correct answers, if not more, before you leave on this quiz. And then take the rest home. And that gets you, while you can finish it, wouldn't that be great? If you finished the quiz and you were all right, then you feel good. If you have time to finish this whole thing, I'll tell you if the answers are right or wrong. Then you can select quizzes. Everybody else have their graded quizzes, 4 and 5, right? That they can refer to.